Welcome to Decoded, the podcast that explores how data, technology, and human insights are reshaping patient care worldwide. I'm Yuri Kamlon, biologist, dreamer, and founder at Sophia Genetics. In each episode, we decode insights with the pioneers using data not just to imagine, but to create a new reality in healthcare. Today, I'm joined by Dr. David Rhew, Chief Medical Officer at Microsoft and Adjunct Professor at Stanford University. David is more than a physician or a tech leader. He's a visionary who brings bold ideas to life, transforming healthcare through responsible AI and multimodal data. David champions initiatives like the Trustworthy and Responsible AI Network and drives the evolution of cloud-to-edge solutions that enable care for every patient anywhere. Together, we will explore how data empowers healthcare professionals, unlocks actionable insights, and how responsible AI is changing medicine at scale. Let's dive in. Good afternoon, David.
Good morning. Good afternoon. Hello. Thank you for inviting me.
You're welcome. It's my pleasure. David, maybe to start with, Microsoft is today one of the largest, if not the largest company in the world in terms of market capitalization. How do we end up being the chief medical officer of such a tech giant?
I can tell you my journey was like a hobbit's journey, an unexpected journey. I did not ever anticipate when I was in medical school or even before then that I would be working for a technology company. Most of my ambition was really around how can I do something that will be beneficial to help people. The vision I had as a child was I wanted to be a doctor. I had that for many years. And when I went to college or university, I was also interested in this area, which I think a lot of my peers were, which was video games. And so I was very interested, particularly the arcade video games. And I always thought, boy, it would be really neat if I knew how to program or build those games. And so I was given the opportunity to study whatever I wanted when I went to university. Of course, I did the pre-med because that was sort of my initial feeling. That's what I wanted to do. But for fun, I did computer science. So as part of my computer science degree, we had to write a thesis at the end. And my thesis, and again, this is in 1988, was AI in healthcare. So that kind of got me thinking about it. But, as you can imagine, there wasn't a whole lot of AI in healthcare at the time. So it was pretty much put on hold. I went to medical school. I went to residency. When I was approaching the end of my residency, I had to decide what I wanted to do for my career. Did I want to go into clinical practice or did I want to continue to do more fellowships? But one thing that was really fascinating to me was this whole concept of why, when you go into a hospital, is there so much variation in care? And literally, for the same conditions, we would see patients treated differently. My question that I had at the time was, well, is that variation in care warranted? Does it really make a difference? And so I spent a whole year studying that as part of a fellowship in an area called health services research. It turns out that a large part of it is unwarranted. Many people do things not because they're the best things to do, but it's like you don't have the right information at the right time. And so I began studying evidence-based medicine and really understanding, well, what is proven and how do you get people to do what's proven to be beneficial? And that then got me down this path of building out what are called guidelines. And then the whole point was I was running around the hospital presenting guidelines to clinicians. I said, there's got to be a better way to do this. And so I started building some structures or templates that allowed us to be able to put them into electronic health records and really make it automated. As part of that process, I built what's called an evidence-based order set. It was actually one of the first evidence-based order sets that was ever built. And what we did is we created that into a product. I was part of a company that was part of Cedars-Sinai at the time called Zinx Health. And as part of this company, we sold this product. And then it was acquired by Cerner, which is a large health IT company. And so that literally got me from this idea of just thinking about how do we reduce variation to becoming a little bit of an entrepreneur in this space to now all of a sudden becoming part of this very large health IT company. And literally from there, that's when my career took a pivot towards health technology.
Amazing. And you did your med school in University of Michigan. AI was a bit mystic at that time. It was not what it is today. You were a kind of Doctor Strange.
Yes, very much so. In fact, I would say at the time, the AI, the programming I used to do a lot in was Lisp. And that was it kind of record this big mainframe computer. And it was hard to imagine that you could ever envision this because a lot of this was still algorithmic and you had to kind of put all your knowledge into this system. But yes, it was a very unusual time. I remember applying for medical school and it was really, you would think it would have been an advantage to be able to talk about AI and technology. I think in many ways, people looked at that kind of strange. They're like, well, why are you focused on that? That's not really medicine. So fast forward to today and everyone's talking about it. It seems so strange that back then people really didn't embrace it.
Amazing. David, after your studies and your experience on trying to bring data into healthcare to make it more equitable, to objectivize decisions and so on. Indeed, you've been one of the founders of ThinkCell, sold to Cerner, as you said. Then you've been working as well at Samsung Electronics. And then more recently, I think it's now 6 years, you've been working on Microsoft. Can you give us a sense of what is your daily life at Microsoft as a chief medical officer?
That is probably one of the most common questions I get asked. Like, what does the chief medical officer for Microsoft do? And in fact, I think my mother would like to know the answer to that question as well. But I'll tell you, what's exciting is that the technology is advancing to the point where we can do amazing things. And part of my responsibility is to understand a bit about how that technology can be applied in a very complicated, regulated space such as healthcare. And so that translation of amazing technology that's constantly evolving to something that needs to be done in a safe, consistent, equitable manner that is very workflow dependent and requires a lot of adoption from multiple stakeholders is really my job. And so part of what I've been focusing on is how AI can be applied in ways to help clinicians make their lives easier, change the concept of increasing access to care, improving quality and safety, much of what I've focused on originally, and also trying to find ways that we can improve the overall efficiency of care. So these kind of key principles of what we focus on in healthcare, AI is a tremendous capability that we have now that allows us to be able to do things that we could never have done. And that's really my job, to make sure that that is done in a way that organizations will feel comfortable with it and will adopt it.
And in that note, one time you told me that you're like a translator, right? Because indeed,
Yes.
medicine is complex and evolving very rapidly. On the other side, technology is complex. Not everyone even yet understands what cloud is about, which is computing data basically outside your computer. And now comes AI. So I think you spend quite a lot of time as well in conferences on explaining how we can combine technology and science for the benefit of patients.
Yeah, and it's really kind of in a couple of different categories. One is at the individual or organizational level, I'm trying to get people to understand how the technology can be used to make a meaningful difference in what they're accomplishing. But also, I'm starting to realize that many of these problems cannot be solved by one organization, including Microsoft. And what we have focused on is how we can work together to be able to build these collaboratives, to enable data sharing in privacy preserving collaborations, to allow for federated learning, to be able to enable us to be able to leverage the power of the masses and be able to do things that one organization couldn't have done. And much like Sophia Genetics, we are focused on the power of how we can do collaboration, but also doing it in a way that people feel comfortable with. And so that's also been a big part of what I do. And because of that, sort of that desire to be able to bring organizations together, I've been involved in many of these collaboratives around building networks for enabling trustworthy, responsible AI, building networks of organizations that are all working towards increasing access to care by leveraging AI applied on retinal images to screen for multiple different conditions. Now starting to work on initiatives to enable us to be able to create programs around AI skilling and reskilling. And so this is like something that is also very important. It's not just about the technology doing one task, but how we work together in ways to be able to transform the industry.
Can you give us the example of analyzing the retina with images and AI, some concrete benefits of that? I found it fascinating personally.
Yeah, well, thank you for asking on that because this to me also is very fascinating. And I feel like it is something that gives us a little insight into like why technology takes so long to be adopted. So this whole concept of applying AI on retinal images is called oculomics. And this has been around for well over a decade. There have been some amazing research that shows that we can apply AI on a retinal image. And a retinal image can be obtained through just a routine eye exam. So like this is not something that requires a significant amount of effort. You go to the eye doctor, you do those, go to the machine, it's called an OCT, and it says, is it better or worse? And that image that's captured, you can run the AI on top of it. And what we can identify are things like diabetic retinopathy, cardiovascular disease, chronic kidney disease, hypertension, ophthalmologic conditions like macular degeneration, glaucoma, and a whole series of even potentially neurodegenerative conditions like biomarkers for Alzheimer's, MS, Parkinson's. Now, clearly, the diabetic retinopathy is the one that is most mature. It actually performs better and more consistently than many clinicians. And so it's FDA cleared, it's got a CPT code and all these other things. But the thing is, because of the fact that it was just really, we were only focused on doing the AI, the workflow was one of the main issues. And there were many other factors. Think about it. Back then, 10 years ago, in order to do this, it took 20 minutes for a clinician to capture the image. On top of that, 40% of the time you had to dilate the eyes to capture the image. And the clinicians in a busy day, they didn't even get paid for it. Okay, so like these are all barriers to adoption. Well, now every one of those barriers has been removed. We actually can do this in 2 minutes, non-invasively. Does not require a clinician. In fact, all you do is you just push a button. Doesn't require dilation 99% of the time. And there's a payment model for this. So we've now realized that the time is right for us to start taking this amazing technology and bring it not only in eye care settings, move it outside, move it into like primary care, malls, kiosks, schools, bring it into homes. There's a tremendous opportunity. And when we think about that, now we've changed the whole concept of where care can be accessed. We don't have to go to a doctor's office.
Absolutely.
And that's what's so exciting about this. This could be done. It's high impact, low cost, highly accessible anywhere around the world. And we could really change the concept of how care is delivered. That's what's exciting to me about it.
Oh, look, I love this example, right? Because it's precision medicine, but with a setup that already exists despite the workflow as being optimized and so on. And the impact indeed in terms of prevention can be huge on this one.
So I actually think that the problem is not so much finding the disease. We actually can, there's many modalities. We can use AI and retinal images. We can look at medical records. We can use voice as a biometric. But the issue is we're starting to see there's so much disease, sending it over to a system where they have very limited number of clinicians and specialists is actually the rate limiting step. And so as part of this, what we call Alliance for Healthcare from the Eye, our focus is first, find the disease, but second, risk stratify the individuals so that the highest risk individuals are seen urgently, and then manage the low risk individuals in a way that does not tax the system. And that means figuring out ways that we can do this digitally, virtually, through low risk channels. And then on top of that, finding other care providers that may potentially be able to take care of that overload. Because if we throw it all back into the system, it creates a massive overload and ultimately patients cannot be seen. And that's actually one of the biggest things that we're focused on. How do you manage the large number of patients that need to be seen? And a large part of that has to do with risk stratification, triage, and capacity building. And that AI can also help in that category as well.
Of course. And actually what you touch is super important because obviously you and I are passionate about technology, science, AI. But what you are telling is that medicine will still require humans, practitioners, and we have to be careful on managing things so that we can help them do their job maybe better, more precisely, but not overwhelm them with more activities, which could be a pitfall as well. Absolutely.
Absolutely. And the other thing we're seeing is that there's such a tendency to want to say, oh, AI can do things just as well as a clinician. But is the goal to replace the clinician? The clinicians are such a valuable resource that if we actually do that, we don't really change the whole paradigm of how we scale and how we augment care. Let me give you an example. This has actually been shared in public settings. I'm not going to use any names, but there was an individual that went into an emergency department and had severe abdominal pain. And that individual died. He had an aneurysm and a burst. Now, the CAT scan that showed that aneurysm before it burst was actually in the queue to be read by a radiologist. And so let's think about that. If AI could have been applied on that image, we could have bumped that to the top of the queue and had that person potentially seen earlier. This is what we mean by when we say augmenting care. We're not saying let's replace that radiologist because the AI can do it. That wouldn't have had an impact on the care. What would have the impact is if we scaled that radiologist to be able to be everywhere, in fact, right at the time that you came in. And that's what we have to focus on. How do we augment care? How do we make things better by bringing capabilities to us that we don't currently have? And that's the opportunity that we really have to be focusing on. How do we make sure that high value activities are augmented through the use of AI as opposed to simply trying to replace what we currently do?
Absolutely. And maybe we will go into that in more detail. And I think this is what people call the AI agents, right? An agent that could tell you, okay, these are basically the most severe cases. So focus on those ones as the radiologist to take an example. And I know that at Microsoft, you talk as well about an orchestrator of the AI agents. And recently we discussed about the utility on the virtual tumor boards. First, taking a step back for all the listeners, can you give us a sense of what is a tumor board and why a tumor board is important in the context of a specific patient with a cancer before you explain us how, with your Microsoft capabilities, we're powering up the humans which are being part of this tumor board?
Yeah, thank you. This is such an important topic. Cancer care is better when you have specialists looking at your care, when you have a lot of different opinions, when you're looking at the evidence, when you're trying to compare to see whether you're eligible for certain trials, when you have all that information, all being synthesized and organized in a way that all these different viewpoints are now taken into consideration, you get better care. It's called multidisciplinary care. Now, the problem is that it's very time consuming to first pull all the medical information from the medical record, to identify the information that's relevant from the medical literature, to identify if you're eligible for certain trials, to get different opinions. Less than 1% of cancer patients receive tumor boards or this multidisciplinary. There's a large number of individuals all looking at different aspects of the care, trying to provide the right recommendations. But the question is, how do you synthesize all of that? And because of the fact that you've got so many different folks focused on different aspects, we're now starting to realize that having an ability, not just for them to get together, but really taking ability and look at what is it that they're doing that could be automated. And in many ways, the things that we just talked about, pulling information, summarizing it, and creating a longitudinal timeline and having an ability to query that, all of that can be done through what we call agents or AI that's specifically designed around that. And now imagine agents that are focused on different categories. Maybe down the road, we may have agents that are taking a look at it from the cost perspective, agents that are looking at a quality perspective and a safety perspective, agents that are looking at it from the patient perspective in terms of like what their preferences are. And you have all of these all then working together. That's what we're talking about with this virtual tumor board now being used in a way that allows us to be able to pull these different agents together. But at the end of the day, it's about agent to agent and agent to human and human to human communications. And that means we have to orchestrate this. And so if you think about this like an orchestra, you've got parts going on at different times. You need the conductor. And the conductor ultimately has to be done in symphony. What we've come to realize is that in addition to having agents, we need these environments that enable collaboration. And one of the collaboration environments that Microsoft has offered and is actually available for 99% of most organizations that are using collaborative tools is Microsoft Office and Teams. So simply using Office and Teams, we can collaborate synchronously and asynchronously with these agents. And that's what's really exciting about this. You've got the ability for agents to do what they need to do. You've got an ability for us to be able to then do collaboration. And we hopefully will accelerate the time to do tumor boards, and we will increase the number. And that will have a direct impact on patients.
And obviously, in the spirit of what you were describing before as well on eye disorders or the power of retinal imaging to be able to infer additional information around diabetes or around cardiology and so on. Here, the spirit as well, I guess, is that the more cases we do on the virtual tumor board, right, the more we have the pathologists, the oncologists assisted by agents that are working together, the more we build a collective intelligence to better and better serve the next generation of patients, right? Because I guess we can learn from the cases of today to better support the cases of tomorrow.
Absolutely. You're hitting on something that we talked about earlier, which is, we can learn from each other. You learn from their experiences. So, like, while we may have synthesized all the best information that we know today, by simply having the patient go through their course and tracking, that's another piece of information that could be used to inform other patients. So absolutely, we're at the point right now where the digital component, the ability for us to capture this information, we can create new evidence sources. And that may end up becoming the way that we think of evidence-based medicine in the future. Not so much about randomized clinical trials, but about real-world experiences that people have that we can now tap into.
And the importance of recording data. As you started as Inks a long time ago, late 90s, early 2000s, so that once data are being recorded, we can compute them. And beyond AI, we can deliver a collective intelligence. And in that regard, David, where do you see AI impacting healthcare in 10 years' time? What do you think will be the most important things that we will see?
Obviously, the things that we're going to see most immediately are the ways that we can reduce a lot of the friction points. There's so many things that clinicians have to do today that are administrative in nature, documenting the electronic health record. And I think that in itself is going to change the workflow for a lot of clinicians because you make things easier for them. They're more likely to adopt it. And then all of a sudden you've got a new workflow. So now we start thinking about what does that new workflow look like? It's going to be what we call ambient. Ambient means it just automatically happens. The voice conversation we have with a patient, that will then be captured and now be brought into the medical record. The video that we have, simply looking at things, it will also capture things and be able to document things and allow us to be able to understand. And then having all the AI in the background with all this new information. So we're capturing information in different ways. The AI allows us to be able to analyze it. And again, that can also be done in the background. And what happens is when things bubble up to the top saying, hey, this is really important, we have to figure out a way to make that information actionable. And that's when you get into the agentic piece. So it's really going to be two parts. One, gathering all the information, the workflow compatible pieces, generative AI, machine learning, natural language processing, the visual AI, the voice AI, all of that is in that category. But then you've got this agentic piece, which now needs to be orchestrated because there's a lot of agents all working together. And throughout this whole process, you've got hopefully the individual, the clinician orchestrating a large number of these technologies. And that is where the future is heading. The future is heading towards this orchestration of the ability to be able to gather new sources of information and then being able to act on it. And that's, to me, one of the things we're just now starting to see how it can be done. We're starting to see the use of agentic. We're starting to see how orchestration can occur, but it will eventually be done in a way that is going to be much more seamless.
And there, I guess, ultimately, it means more democratic, more accessible, more equitable, as you were explaining on the earlier cases you've been covering.
Yes, absolutely. We oftentimes talk about how AI is really going to increase the digital divide because the technologies will be only available and accessible for those that can afford it and that can use it. But many of the things that we talked about we're getting to the point where the price points are coming much, much lower. And the ability for us to be able to move this outside of places that are usually reserved for people who can afford to or can have the transportation to be able to get to the clinicians we have an ability to democratize all of that, starting with democratizing knowledge. We can democratize it with already sort of like the chat GPT like interfaces. We actually just recently had an announcement of, I think, an extraordinary type of approach that allows us to be able to take AI and ultimately come up with better diagnoses that are more cost efficient than looking at with, I'll say, a traditional approach. A traditional approach of maybe having clinicians taking a look and trying to make a diagnosis. In this one example, we looked at New England Journal of Medicine case studies. 20% of clinicians were able to get the right answer, or the clinicians were able to get the right answer 20% of the time. And with this model, this AI model, it was around 85%.
Wow. And what was it about? Which disease was it about?
Multiple conditions.
And so what you're describing, obviously, is that if data are available, even in remote places, maybe in some, I would say, rural places, let's say in Texas, those people will benefit from the same diagnostic yield as if they would go to MD Anderson.
Well, that's really the promise. This was just more, I'd say, still in the research setting, because there's still a lot of things that need to be done to operationalize it. But it gives us a glimpse of how the AI could be helpful. And not only that, it was more cost efficient, which is also extremely important. And so as we think about this, and what do they do? This is really interesting. They had different agents focusing on different things. There was a hypothesis generator. There was an agent that was figuring out which tests to deploy. There was an agent that was looking for the most cost efficient mechanism. There was an agent looking to see whether it met certain protocols, and they had a checklist. And all of those agents like communicated with each other. And that's really where we're getting towards subspecialization, where the AI does certain things, and then an ability for us to kind of have all those different voices, have that conversation, and ultimately come up with a final conclusion. That's exciting.
And so important indeed, because healthcare budgets will not continue to grow despite population is getting older. In that vein, you share with us your thoughts on what will be the benefit of AI, this equitable, accessible, democratic, I would say, medicine, right? Where knowledge will be shared. But what are the hurdles that we need as actors in healthcare, in AI, to fix so that we can make these opportunities be applicable quicker?
Yeah. I like to think of it in terms of like two major categories. With all the amazing AI, it would be such a shame if we didn't take advantage of it. And why wouldn't we take advantage of it? One, we may not trust it. May not trust that it works well. It may not trust that it's addressed the concerns that we may have about propagating bias. We may have concerns that perhaps it might drift and perhaps may change over time. There's a lot of concerns that we have. So trust is the first element. But the second is skills. Do we actually have the skills required to be able to utilize this? Now, while AI makes things a lot easier, as I mentioned before, ultimately there has to be some level of orchestration. With all these agents running around, who's to be able to determine how to best utilize this to result in the best outcomes? That requires level of governance that we don't have today. And that those two elements, building a trust in the system and in our capabilities to be able to govern this, is one. And then the second is having us actually at the individual level be able to have a knowledge and understanding of how to apply AI proficiently. And so I'll just share a couple of things that are already underway in both of those areas. Around trust, I think many organizations have come to realize that trust is an essential component, but they've also come to realize that it's more than just simply relying on a developer to do some testing on this. It actually has to do with, I'll say, 5 key things at a minimum. One, do you know the AI that's running in your system today? And if you don't, you probably need some kind of a system to be able to do an inventory, sort of what we call a registration of the models, capturing it in a standardized way, something called like using model cards. And so that's like the first thing, understanding what's out there. The second, have you tested those models on local data sets or on large, diverse data sets that are representative of your population? We can't rely on the fact that just because a model was tested in one environment, it'll work everywhere. And so that ability for us to be able to local testing and be able and using these large, diverse data sets that are representative, that would be very helpful. And that's pre-deployment. But the third is post-deployment, have you continued to monitor to see that it's actually working? Because there's something called drift. Because these models change over time, the data sets change over time, the patient populations change. So we may see differences in the way that these models perform. And you won't know that unless you monitor it. And so this whole concept of putting in systems to monitor is extremely important, and actually something that most organizations have not yet gotten to the point of doing. The third is, have we specifically looked for bias? Bias in the models and bias in how it's deployed and bias in how it's impacting the populations. Those are very important things that we need to also be monitoring for. And lastly, I mentioned governance. We have this one example. There's a site that we've been working with. They have 5 people monitoring one model. That's a lot of people monitoring one model. That is completely unscalable. We have to automate that process. We have to figure out a way. And so trust is a big area. And what we found is that the way that we can address this, you can either throw a lot of people at this, which is not scalable, or we can leverage technology. Leverage technology to the point where we can actually make things better, faster, more efficient. And that's what was launched with the Trustworthy Responsible AI Network. And so that's one category. The second is we have to upskill the entire workforce. We're moving so fast that the workforce, they're looking at AI and they're either saying, well, it's going to replace me. I'm not going to do it. I don't know how to do it. We have to figure out a way. And it's got to go beyond building a curriculum. It's got the curriculum's the foundation. And then we have to create a level of experience, or I should say training, that people know how to use it. So a great example would be, we've seen something called a promptathon. It's like a one-day session where you teach people how to do prompt engineering. It's very easy to learn, but the outputs that you get relative to generative AI are highly dependent on what you put in, the questions that you ask. And if you ask the right questions and you have it done in the way that you're having a conversation and it's iterative, that is far more effective than simply using it as like a search engine to ask one question. We learn that people have different approaches and there are better ways to do this. So teaching people how to do it. And lastly, make it such that we actually, at the end of these courses, there's a job at the end of that you've skilled a person so they knew how to do their job. And if that you can do that, then we have really transformed into the way to be able to increase adoption. So those are really the things that I think will allow us to be able to get to higher levels of adoption.
I love what you say, because I'm truly convinced as well that to have an impact in medicine, we need to continuously onboard the practitioners, the nurses, the oncologists, and so on. And what you are describing is exactly that. First, the technology need to be trusted for its capabilities and continuously. And second, the people need to trust that the technology is a partner and it's not something that is going to replace them. Maybe, David, to end, I would have had many other questions for you, including, whether AI will prescribe drugs in the future, where eventually there might be some risks about drifts or so on, but we may cover that another time. But you've been talking about education. What are your words, your thoughts, any advice for the new generation of doctors and computer scientists?
One of the things that I've learned is that oftentimes there is such a desire to be a specialist right away. And this goes beyond computer science and medicine. I'm just talking about, like a lot of times people, they find their child's good at one sport, and they say, I'm going to only put you in this one sport and you're going to be the superstar. Well, we've actually learned that cross-training is really important. And cross-training is not just in sports, but it's also in education. You learn a lot of different things, and you find that it's the blending of these skills that ends up becoming the opportunity down the road. For me, it was computer science and medicine, kind of blending those two completely different areas and putting it together. I don't know. One of my favorite candy is called Reese's peanut butter cups. So you got peanut butter and chocolate, two things that you don't think of normally. Put it together, you got some great tasting candy. But in the area of healthcare, we are starting to see technology merge with this, obviously the healthcare component, but also what we call health services research, which is an area where I personally started because of curiosity. But it was really about how do you evaluate studies? How do you demonstrate ROI? I mean, you can't do what we do without showing that it actually works. And so that's another skill set. And then for me, just inadvertently being a part of a company that became sort of a startup that grew into something, that entrepreneurial, that business element was very important. And so like, how do you do this? Well, you could go, and one way is you can start taking courses and learning that, but also just doing it. Boy, I mean, I learned so much just by doing all of this. And that to me is how you put it all together. You learn a little bit here and there, you find what you like, and you create these combinations that work well for you.
Explore, don't limit yourself, be curious. You told me one other time, take the blinders out. I love it. David, thank you. It was a real honor to host you. Your vision combined with the practical insights you've shared today highlighted clearly that the future of healthcare is both digital and deeply human, rooted in trust, transparency, and bringing meaningful insights directly into patient care. This was Decoded. I'm Yuri Kamlong. Join us next time as we continue exploring the people, the ideas, and the innovations reshaping healthcare. Until then, thank you for listening, and let's keep moving forward together.